Hi all, we'll start with new topic. That's a new model, fourth model, signals. Okay, so, so here, what all things we'll study is what is signal, how signal handlers are there, okay, how internally signals are managed. Okay, so whenever you will create any signal handler, okay, so what all default actions will happen, okay, and kill command and this alarm signal. So then sig child, okay, so wait PID or whenever signal will come, that time how long jump and set jump will do it. Okay, those will study it. Okay. So first, what is signal? Okay, so here a signal is nothing but it's kind of software interrupt. Okay, so whenever interrupt will come, so what normally will do is the system will do is so it will give the first preference to the interrupt only. So hardware interrupt, if it is there, it will give the first preference to the interrupt. So that time interrupt will run. Okay, so our interrupt handler will be there, some kind of things, so it will perform the task. Okay, so sometimes you can ignore the interrupt also. Okay, so those are the rare cases ignoring it. Okay, so or by default it will kill the order process you are running it. Okay, same thing, this is a software interrupt. So normally you had the hardware interrupt. Okay, so same thing, this is software interrupt now. So whenever signal will come, there is something software interrupt will come. So processor normally it will take the first priority for the that interrupt handler or whatever default action is there for that interrupt. Okay, that is nothing but for the signal. So what kind of things will be there? So suppose I am running one program. Okay, so it's in maybe for the execution it's taking of some 5 seconds or 10 seconds. So before completion of that program, okay, so in between I'm pressing the control C. Okay, so sometimes in control X, okay, in terminal. So what will happen is immediately that process will get interrupted and it will stop it. That's it's nothing but that process will terminate it. Okay, so whatever we did is that is control C or control X in some system. Okay, so what happened is we given the external interrupt. Okay, that external interrupt is nothing but a software interrupt we given it. Okay, so we are saying as a kill the running process. Okay, so that is a signal we given to the kernel. Okay, so that kernel by default it will take the action. Okay, so for a default action for this one is for the signal kill is the thing what whatever process is running that it will kill it and it will stop there only. Okay, so this is the action it's taken. So like that you will be having different signals. Okay, so what are those signals, how it is operated, those things we can see it. Okay, so whatever signals we have, so for example, so all these are listed as macros. Okay, so those macros are defined in signal.h file. Okay, so it's defined in signal.h file, and always starting you will be having the three letters sig, then after that followed by maximum four letters will be there. Okay, so it can be sometimes it may be three letters or two letters after sig, so depending on the whatever kind of signal is there. Okay, so maximum normally it has the four characters. So whatever we have, those all are listed. Okay, so here if you take example as a signal abrt. Okay, so there's nothing but about. Okay, so internally it will call the about function. So so whichever process is running, so it will kill it. Okay, and here sometimes signal will maintain the one core gen file. Okay, so what is that core file is nothing but when it is stopped, what all things have happened previously. Okay, so those things it will maintain it, kernel will maintain it. Why it is stopped. Okay, so whichever process you are running it, if some signal came, so the process is aborted. Okay, or it's killed or terminated. Okay, so why it is killed, so what is the argument for that signal, so those things will be noted down in one file. Okay, that is will normally will call it as a core file. Okay, so that file whatever is there, that will be generated for some signals, and for some signals it will not generate it. Okay, so what all those things also we'll study it now. So okay, see here. Okay, so condition to generate the signals. Okay, so first thing is it's a terminal. From the terminal we were discussing when process is running, so we'll give the control C. Okay, so automatically the signal will be taken, and it will stop the whatever process we are running it. Okay, then signal from the hardware also will come. So it's like SIGFPE. Okay, so it's something, but whenever you have the floating point error, okay, so whenever you have the divide by zero, okay, or any segmentation error is there, okay, so that time this signal will come. SIG okay, this is a segmentation error. So whenever you will be having some illegal memory you are trying to access, for example, in your system you have only 4 GB of memory, and your processor is trying to access more than that. Okay, so that time segmentation fault will occur. Okay, so and same thing, sometimes owner he himself will call the kill function. Okay, so that time automatically internally whatever was happening, it will stop it, it will kill the that process. Okay, so like, and maybe you set the some alarm, after that alarm timeout, so automatically it will, the signal will be generated. Okay, so you give the some normally you will see as a alarms, you will get the some pop-up kind of things in your normal systems. Okay, so those all are internally written as a using sig alarm only. Okay, so and suppose you want to communicate between two processes. Okay, so you are using the pipe. So if the pipe is terminated, or if it is a underflow or overflow, depending on that you will get the sick pipe error, sorry, sick pipe signal. So here what are actions we can take it. Okay, so whenever signal will be generated, so what are actions we can take it. So normally you have three kinds of actions. Okay, that is, you can ignore it. Okay, ignore the signal, then you can catch the signal and perform the whatever you want to do it, then apply the default action. Okay, so total three things. So whenever we are saying as a ignore it, so like sig stop message signal is came, or sig kill signal is came. So these things you can't ignore it. Okay, so this is the kernel is predefined one. Whenever you will get as a sig kill and sig stop, so that time you have to perform the action whatever default action is there. So other than these things, okay, so you can ignore some signals also. Okay, for example, we have as a uh, signal USR1. Okay, so it's a user defined signal. So here user defined signal is there. If you want to receive that one, you can receive it. Okay, or you can ignore it also. Okay, so depending on that, you can perform some action. Okay, so here some signals you can ignore it, and some you can't ignore. Okay, so here this is for sig kill and sig stop, you can't ignore it. Okay, then catch the signal. So for the signal, so whatever signals are there, so for that you can write your own handler. Okay, there is a kind of some function you can write it. Okay, then you can perform some task, like in normal higher level languages you would have studied as a exception handling. So whenever exception will come, you will catch it and you will perform the action. Okay, so same thing here also. Okay, so here signal you will catch it. For each signal you will be written the some handler. Okay, so you can catch that one and you can perform the some action. Okay, then apply the default action. So some signals already listed as a default action. So, okay, the default action is nothing but killing the process only. Okay, so whatever process is running, that it will get terminated. Okay, so default action, so you can't do anything there, so automatically it will get terminated. So like that some signals are listed. Okay, so some, we'll see some signals now. Okay, so here we have the signal abrt. Okay, there is about. Okay, so internally it will call the about function. Okay, signal alarm. Okay, so whenever system will be generated some timer. Okay, so the timer whenever it will get over, so alarm will be generated. Okay, and then hardware generated signal bus. Okay, so bus 32-bit or 64-bit, whatever bus will be there, depending on that bus you will generate the some hardware signals. Okay, and sig fpg. Okay, so sig fpg here it's nothing but whenever you will have the divide by zero. Okay, so floating point error it will come. Okay, then sig count. Okay, so sig count is nothing but resumes the execution of a stopped process. This is nothing but here is a continue, it's not a value. Okay, cont signal continue actually. Okay, so whichever you stopped, that it will get continue. Okay, then you have as a signal hup. Okay, so this is controlling the terminal hanging up. Okay, so nothing but signal whatever it's terminal it's interfacing. Okay, so that terminal if it's hangs up, it can do it. Okay. So like this we have almost 32 signals. Okay, so stop signal, okay, system, invalid system call, okay, so terminal or trap, okay, so stop the process only, okay, so foreground process it will top it. Okay, so like this, and then you have the something as a user defined signals also. Okay, so two are user defined signals. Okay, so here USR1, USR2, so two are the normally user defined signals are there. Okay, so default action for these things is the termination only. That is a process whichever receives the signal, so that signal has to be terminated. Yes, and then along with that we have the window size terminal window size. Okay, there is nothing but whatever window size is there, it's not proper. That's it. Okay, so this what it will do is it will just ignore it. So default action for this one is ignore. Okay, just okay. Now we'll see. So how signal. Okay, so how signal is written. That is nothing but one prototype for a function. Okay, so here you have the signal is a system call. So inside that you have two parameters. Okay, so first one is a signal number. Okay, then actually handler. Okay, so this number is nothing but for which signal you want to perform this handler. Okay, so here signal number is nothing but is a signal identifier. So whatever we have studied more than this 32, whatever we are saying it. Okay, so these all are the identifiers. So here you can list which signal you want to receive it. Okay, so which signal you want to perform as some kind of action here. Okay, so here is a signal number. Okay, so now these all are macros only. So it is defined in these all are macros which are defined in signal.h. Okay, so these will be having the some integer numbers only. So here this is signal number, then handler. Okay, so here whatever handler is there is if you saw here we are giving the pointer. Okay, and it takes one parameter, that is an integer parameter, some parameter. If you want to send it integer value, you have to send it. Okay, and this is the pointer to the whatever function you are writing it. Okay, so nothing but whatever task you want to do it, that one function you will write it. For that function, whatever address is there, that address you will pass it, that function's address you will pass it here. Okay, so this is a function handler's pointer. Okay, then particular signal for that what you want to perform it. So this is you will pass the signal. So now this binding will happen between these two. So for this signal you have to perform this kind of action. Okay, so kernel will maintain one table. So for this one this handler is defined now. Okay, okay, or sometimes you have three different kinds of actually and constant values. So here handlers, instead of handlers, constant values will be there. Okay, so those values are nothing but sign. Okay, this is nothing but here we are saying as a ignore. Okay, so signal ignore and signal default, DFL. Okay, so this is also is defined as a kind of wide pointer handler only. Okay, so here we'll see it here. It's defined as a hash defined SIG, no, DFL. Okay, so it is no default. Okay, so it is defined as a void. Okay, we don't have any function name here. We are not passing anything, just we are saying as a zero. So zero whatever is there, we are typecasting it to the integer pointer. Okay, so this pointer we are doing it and we are not performing any task. Okay, so in vector table, okay, on kernel normally what it will do is it will maintain the one vector table. Okay, so whatever we are performing the task for that one process, kernel process table will be there. Okay, so in that for each signal one flag will be there. Okay, so corresponding you have the signal handler or not. Okay, so in one table, okay, that is kernel process table. So in that for each signal you will be having the flag. Okay, so there's nothing but you are saying as a you are maintaining the signal handler or not, it will be there. Okay, so if it is there means normally that flag will be set. Okay, so the corresponding handler pointer will be given. Okay, so this here whatever we are saying is nothing but zero, so is nothing but flag will be set, and this task is empty. We are not doing anything, default action we are not doing anything. Okay, so here this is default. So default normally it is a process termination. So whenever we will say as a zero, so automatically this entire thing will take it as zero only signal. So whenever signal will come zero, there's nothing but you are stopping the process and you're coming out of that process. Okay, so it's kind of exit zero kind of thing, or return zero you can consider. If you are running a one process only, sorry, one function in a process, so automatically it will come out of that function. Then ignore, for ignore we have as a 1, so whatever it will come, so that signal will be get ignored. Okay. And one more thing is there, for a -1 there is nothing but error, so whatever we received that signal is a error kind of things. So again this is a kind of ignore only, but just it will give us a error also, whatever we have received, that's kind of what kind of error it will give it. Okay. So here this is the handler, this is a corresponding number. So this handler you can write it as normally three different ways. So you can write it as ignore, sig underscore ignore, or sig underscore default, or you can write one function, that functions pointer you can give it here. Okay, so three things you can write it here. Yeah, and this can take the one parameter, okay, integer kind of parameter. If you are writing your own thing, so that time it can take the one parameter here. Okay, so just we'll see one example. Okay, so here we're writing one signal handler, okay, catch underscore sig. So here we have a, so we're returning, we're taking the one integer number, okay, sig number. So whatever from this handler is there, so that is taking the signal number also. So that is nothing but identifier whatever we had. Same thing here only. So whatever identifier signal dot h file is there, that number only we are taking it. Okay. So for that signal, so this number, then catch related signal handler we are attaching it. So when it will start main, so we are saying as a signal term. Okay, so signal term is nothing but termination. Okay, so term, there's nothing but it's a termination. So so for that, so here termination whatever is there, process termination. For that normally, so what we are saying is run the this signal handler whatever we are defining it. Okay, so here this is the signal handler we are defining it. This signal handler will be called. So whenever this signal will come, so that time automatically this signal handler will be called and it will perform the task. So whatever task is there, that it will perform it. Okay. So and one more signal we are defining is sig int. If this process while running, okay, one two three, it's trying to catch the three signals. Okay, so here if this signal came, so perform this action. Okay, that is ignore it. Okay, so whenever you will come as a signal int interrupt signal, so it will ignore it. Okay, signal segmentation fault, so default action you have to do it. So the default action is nothing but here what we are saying is terminate the process. Default action always will be the termination of process. Okay, and here we given as a pause, is nothing but this process is stopping and it's waiting for a signal interrupt. Okay, so once stopped, so until and unless any one signal comes, this process will be running in a background, that is it's a paused only. Okay, so here it is paused and it's stopped. So whenever it will receive one of the signal among these three, it will perform the task. If it is ignore or default action or whatever signal handler we return. So here this is the address. Okay, so that is nothing but just function name we written. So here this is the function, we return the name. Okay, and this is sig underscore num. So whatever is that value we are receiving it. So what it will receive is this one only, it will receive it. Okay, so here you can put some if condition, maybe one or two different signal identifiers value you can take it, then you can check the different things. Okay, so now this is a simple example we took it. So here again this were what we are doing is for this signal whatever we got it, so this is the handler we are attaching it. So here same thing, handler we are attaching, then just we are printing it, this handler came, so that is what is the number it came, just we are printing it.